This video introduces the Deep Tech Operating System, a computational framework for turning scientific possibility into commercial reality. Deep tech is more than just invention. Computational thinking provides a disciplined framework, replacing the wilderness of a grant proposal and a dream with structured commercial execution, leading to a repeatable, scalable, and economically useful system. Deep tech uncertainty can be viewed as an entangled risk blob. A computational filter forces decomposition, breaking it down into distinct risks: scientific, engineering, manufacturing, market, business model, and regulatory. The problem stops being mystical and becomes architectural. The mindset matrix contrasts the academic and computational mindsets. While the academic focuses on the phenomenon and what is true, the computational mindset focuses on the system and what matters commercially. Scientifically elegant ideas are irrelevant if they don't attach to a real market pain point. The Deep Tech Operating System is built upon 4 cognitive pillars: decomposition, abstraction, pattern recognition, and algorithmic thinking. These are cognitive habits for applying systematic thought to stubborn reality. Pillar 1 is decomposition, the bridge from invention to product. It breaks down ambition into tractable, measurable layers, from core science to scale-up and business model. Pillar 2 is abstraction. This involves ignoring details that do not control the outcome and re-representing the technology at each stage: the lab, the pilot, and commercial. The abstraction translation table shows how to translate from technical representations to customer representations. This translation is the difference between a brilliant invention and a bankrupt company. Pillar 3 is pattern recognition. Deep tech challenges are rarely unique in structure. Avoid reinventing every mistake. Common mistakes include targeting giant markets too soon or scaling before repeatability is proven. Pillar 4 is algorithmic thinking, the commercialization algorithm. Build repeatable workflows, not just prototypes, through a 10-step process, from identifying economic pain to scaling only when the tech and economics align. Algorithms require explicit decision points or capital protection logic gates to protect capital. For example, if manufacturing yield is low, delay scale-up and loop back to process control. Together, the 4 cognitive pillars, decomposition, abstraction, pattern recognition, and algorithmic thinking, form the Deep Tech Operating System. They create an impenetrable protective shell around a venture's technology and capital. Reality in deep tech is stubborn. Deep tech is a game of sequence. Systematically simulate before spending, test and debug continuously, and convert commercialization from a vague aspiration into an engineered reality. Welcome to From Discovery to Dollars, the computational playbook for deep tech. This video presents a systematic framework for translating scientific brilliance into durable commercial systems. Deep tech success is a multivariable systems problem. A profitable deep tech company emerges only when all interdependent components align. Computational thinking brings philosophical realism to this complexity. Explicit assumptions prevent structural collapse. Many ventures fail because they did not know their assumptions. Once visible, these assumptions can be tested. Remember, the simulation is not the factory. There is a mindset gap between romance and reality. The non-computational approach optimizes for scientific novelty, scales before repeatability, and treats commercialization as a mere sales problem. Value must be translated, not merely invented. A breakthrough has no commercial meaning until it's translated into economic value. The metric that impresses scientists is rarely the one that drives profit. The KPI translation matrix prevents teams from optimizing technically impressive but commercially irrelevant metrics. It translates technical inputs through a computational filter to meaningful business outputs. Commercial pathways are dictated by constraint analysis, not heroics. Founders often want to, quote, own the whole stack, but the spreadsheet, which is less sentimental, determines the most viable path. Computational thinking is the shared language of the entire organization. This floor plan shows how structured data flow and algorithmic processes synchronize diverse functions across the enterprise, creating a continuous, closed-loop system. In this OLED emitter case study, the non-computational reflex focuses on great data and launching a company. The solution, however, initiates a computational logic sequence, treating invention as a full system. Phase 1 of the commercialization logic gate focuses on technical viability. This high-fidelity testing gauntlet evaluates the new material's potential before scaling, including scientific validity, device integration, manufacturing compatibility, and economic value. Phase 2 focuses on market reality. This second gauntlet tests customer segmentation, the go-to-market pathway, competitive benchmarking, and the profit logic to ensure commercial viability before scaling. The mechanics of profitability are built on constraints and structured value capture. Computational thinking reduces waste, aligns development, supports scale, improves capital allocation, and shortens learning cycles. The bridge from discovery to dollars is a rigorous framework for systematic commercialization. It moves through stages, from foundation to durable business, requiring validation at each step to ensure scalability and margin viability. Computational thinking serves as the universal API of deep tech. It is the central translation layer connecting the language of the lab, the market, and the spreadsheet, managing complexity through explicit models and constant validation. For technical founders, structured reasoning is not optional. It is the only way to avoid building a scientific cathedral in a financial swamp. Choose the engineered system for a durable business outcome.